chromatography, and spectroscopy. Okay? So guys, sa board exam, nakahati sa dalawang category ang analytical topics. Again, classical and instrumental. If you have heard of your seniors telling you na nahihirapan sila sa instrumental, siguro guys, may part din sa classical na nahihirapan sila kasi hindi naman 100% na instrumental topics ang nasa board exams. I hope clear tayo dyan. So we have instrumental and classical lessons. Okay? Kailangan guys, kailangan may alam kayo sa basics and sa advanced analytical care. So kailangan balance natin yan here in our review for analytical. Also, the questions in the board exam are of two types. Conceptual, andyan na rin ang situational, and problem solving. So maybe your seniors told you, ang hirap ng conceptual, ang hirap ng problem solving. So kung both guys ng questions, both types of questions, nahihirapan sila or nahihirapan kayo, that will be difficult. Okay, that will be a problem talaga. Kaya kailangan guys masanay kayo, kailangan matrain kayo in answering both types of questions, whether it's conceptual, objective type, situational, or may numbers, problem solving. Okay, kailangan guys multi-talented ha. Kailangan parehong type of questions kaya natin. Okay, so now let me show you the first chapter, equilibria. So for the first part, solubility, and later the second part, acid base. So kailangan guys, maalala niyo ang basics ng chemical equilibrium, which we already had in bridging. Again ha, important yung bridging. Kahit sabihin niyo pa, challenge nga agad ako dun eh. Basics yun. Okay, let me remind you guys, basics ang chem bridging natin. Okay, so here for solubility, equilibria, in fact, ito guys ay mga topics siguro na meron na rin kayo ng Gen Chem era ninyo or basic in org. So dito natin nilagay ko sa analytical because these questions always appear in analytical in the board exams. So class, intro lang muna tayo ng mga basic concepts on solutions and solubility, and then ito na, may numbers na tong units of concentration and dilution, pero madali pa. Okay, take note, madali pa. Medyo challenging tong solution stoichiometry if hindi pa rin master up to now ang stoichiometry. So kailangan guys, balikan ninyo ang Chem Bridging 5 where we studied mole and stoichiometry. So since April pa, i-remind ko kayo guys, since April pa tayo nag-aral ng basics. Okay, and then here we will have KSP, solubility product constant. So may numbers na naman, kailangan po natin mag-focus kung talagang nahihirapan sa mga tanong na may numbers. Okay, so guys, let's begin with our basic concepts. So let's recall the definitions of solute, solvent, solution. Very easy. Solute is the substance or component that is dissolved. Solvent is the substance that does the dissolving. Diba? Very easy lang. And the result, the solution, is a homogeneous mixture composed of two or more substances. Commonly, ma'am, yung solute ba natin, solid, commonly or typically. And then your solvent is your liquid phase siya. And then solution is usually your colorless, homogeneous, diba, na mixture. Kasi kapag salt solution, sugar solution, ayun, colorless lang yan. Clear and colorless solution. Pero kung kunwari katulad nito guys, ang solute ay colored, ang solvent ay colored, syempre asahan nyo, colored din guys sa magiging solution. So this depends on the nature of your solute and solvent. So ma'am, kailangan homogeneous, yes. Kailangan clear, kailangan one phase. Kita natin na one phase lang, uniform gas ang form na solution. Okay, ma'am, ang solute ba pwede maging solid, liquid, and gas? Yes, ang solvent din guys. Kaya later we will discuss in table 1 the possible combinations, the possible pairs. Okay, now in the on-site sections, when nag-ask sa akin guys, ma'am, paano kung parehong liquid? What if your solute and solvent are both liquid phase? How do you know which one is the solute and the solvent? Based on the definitions guys, the solvent must be the one present in greater quantity. Okay, kasi nga it is the substance that dissolves the your solute. Okay, so ganun siya guys. So later we will talk about possible examples. Okay, so here let's see guys, ayun, may nagpo-form na solution here. Oh. Okay, so yan. So the solute here, ayan, it's your solid, and then your solvent class is obviously the liquid here. And sinistir lang nga, okay, to aid the particles to dissolve into solvent. Okay, so yan guys, ang pag-form ng solution. So now, examples nga ma'am, para mas magkaroon tayo ng more clear na grasp sa mga concepts natin. Rubbing alcohol solution. The components are both liquid. Your rubbing alcohol solution contains ethyl alcohol or isopropyl alcohol and water. Another example, class usong-uso to, di ba? Gusto nyo ng instant glow up drip. So mga gluten drip na sobrang uso ngayon, this contains glutathione and vitamins. Ano yung solvent nila? Usually the solvent is either dextrose or saline solution. And then guys, syempre, ang soda, carbonated drinks or commonly known as soft drinks. There are a lot of solutes present here. Syempre, alam niyo na, maraming sugar yan. Marami pa ibang components. And yung magiging highlight natin later na gases dissolved in liquids, ito, kasi you have carbon dioxide dissolved in water. Kaya nga carbonated drinks. And then lastly, we have vinegar. This has acetic acid and water. So class, sa mga examples na to, we can already demonstrate yung mga concepts na we need for the solute-solvent combinations. Okay? So here guys, ang mga components ng mga solutions na ito. Okay? Now, if you notice guys, may mga factors to consider. Okay? And one factor to consider guys ay dapat compatible ang solute and solvent. Kaya para ma-form class ang solution and solution formation, these two interactions must be overcome. What are this? Your solute and solvent interactions. Syempre class, kailangan ma-break to para mag-form naman ang new set of interactions, solute and solvent. Okay? So kailangan ma-overcome nila itong barrier na to para maging compatible class ang solute and solvent. Okay? Let's see naman guys, itong did you know slide natin. Mamano yan? Class, ito solvent ha. Okay, solvent yan surrounding our solute ions. If it were general solvent lang, we will call this solvation, the interaction of any solvent with ions or molecules. Okay, but if it's specific na water, ang tawag class natin dyan, hydration. Familiar na sa inyo, di ba? Sa organ, baka narinig nyo na to. So, example, if you have methanol solvent surrounding sodium, it's the interaction of any solvent with ions or molecules, solvation. Ito class, kung nasa video natin, obviously, this is water surrounding the ions. So, ito yung process guys kung paano nag-interact ang solvent, paano dinidissolve ng solvent ang solute species. Okay? So, kailangan lang i-define na yung mga words na yan kasi baka nalimutan nyo na. Okay? So, now guys, let's move on to another basic concept, solubility. Solubility is the maximum quantity of solute that can dissolve in a specific amount of solvent at a specific temperature. For sure, hindi pa nalilimutan to guys ha. So make sure na kung dapat unit ng solubility. Later in KSP, you will know na ito ay pwedeng molar. Kung gusto mo naman in grams, i-multiply mo lang with the molar mass. With respect guys sa solubility, kung ano yung current concentration ng solution, we have three types of solutions. Unsaturated, if it can dissolve more, meaning concentration is less than solubility. Kaya nga siya not yet saturated. So it contains less than the maximum amount of dissolved solute, it can dissolve more pa. More, sabi ng solvent, give me more. Okay? If it's saturated, hanggang dyan na lang. It contains the maximum amount of dissolved solute at a given temperature and pressure. So concentration is equal to solubility. Puno na, saturated na. Eh man, paano kung nag-add pa ako ng more solute, just like highlight in the picture here, then gusto ko siyang gawing super saturated, then you should increase the pressure or temperature. Of course, guys, sa bahay, mas madaling initin ang solution, di ba? Initin mo, okay, para yung added solute, ma-dissolve pa siya. May effect ba kapag naging super saturated ang solution? Well, initially, you will see naman na clear pa rin to, okay, clear solution pa rin to, but it is unstable. So if you add crystals, or if you disturb the solution, it can form crystals, guys. Mag-crystallize siya. Okay, mamaya ko ng example, yes, para mas magets ninyo how to create a super saturated solution at paano siya naging unstable. Watch this.
Supersaturated solutions are inherently unstable. If you add a small crystal to this metastable supersaturated solution, bam, crystals start to form throughout the solution. To make a supersaturated solution, we start out with pure water, just H2O. That's our solvent that's going to dissolve these crystals here. We put the crystals in, they're called the solute, and they dissolve. This is an unsaturated solution since we can keep dissolving more of the solute, more of these crystals. The crystals we're using here are called sodium acetate, and everything in that beaker, ultimately it's going to dissolve. After a while, no more solute will dissolve at room temperature. Now we say the solution is saturated. But if we heat it up at that new temperature, all of this is going to dissolve. And here's the awesome part. When it cools down, the solute, those crystals, they stay dissolved. We say the solution is now super saturated. It's holding more solute than it would at this lower temperature. We drop in a seed crystal, or sometimes just touch the glass, and the crystallization process starts. We can heat it up again, and let those crystals dissolve. And as we let it cool down, we'll have our supersaturated solution again. This is Dr. B with Supersaturated Solutions. Thanks for watching.
Okay, o nakita na guys ha, hindi na nga lang pinakita sa video yung heating stage niya. But yung association yung kanyang saturated solution na nilagyan pa ng solute, hinit niya yun to arrive at super saturated. And then, nilagyan ng class ng seed crystal, boom, nag-crystallize. E paano gagawin super saturated ulit? Hindi heat ulit. Okay? So yan guys, ang super saturated solution. Okay? So now guys, let's move on to table 1. Let's look at solute-solvent combinations, factors affecting solubility, and general trends. First na solvent natin, liquid. Very common kasi guys. So liquid solvents can dissolve solid, liquid, and gas solutes. And here at the third column are the factors affecting solubility. For solids guys, dissolve in liquids. The general trend is higher temperature, higher solubility. Okay? I know, alam niyo to. Example, salt in water, sugar in water. Okay? Next, liquids and liquids. So, ito klase kanilang factors, polarity, temperature, and proportion. At very popular ang rule of thumb na like dissolves like. Kailangan lang, di ba, compatible? Yes. Kaya nga ang alcohol in water pwede. So, low molecular weight alcohols like ethyl alcohol and isopropyl alcohol can dissolve in water because both are polar. Acetic acid in water is also possible. So, when you dissolve vinegar in water, compatible, parehong polar. Paano kung non-polar? O mga organic compounds, guys. Di ba, ang mga organic compounds, they're soluble in organic solvents. Okay? Next, gases and liquids. So, we have two factors here, pressure and temperature. I hope you remember class, Henry's Law. Lumalabas na parati in Chemtech. Okay, tandaan na sa Chemtech, lumalabas ng Henry's Law. You'll have a more detailed explanation on Henry's Law in Pchem. O for sure, 1A. Kung nasa Pchem na kayo, you have heard we have seen in the manual that we have Henry's Law in Pchem. So the higher the temperature, the higher the solubility. You are forcing the gases to dissolve into liquid. Now, conversely, if you have lower temperature, mas malamig, you are increasing solubility of the gas in liquid. Meron tayong picture nito guys later. So ang directly proportional ay pressure, inverse naman ang temperature. Example, oxygen in water. Di ba meron dissolved oxygen in water and carbon dioxide in carbonated drinks or soda. Meron tayong picture mamaya guys para ma-emphasize ulit natin to. Lumalabas kasi itong type na to ng solution in Chemtech board exam. Malay nyo, meron din sa chemist. Okay? Next naman class ay ang mga solid solvents at ang kanilang mga solute na pwede ring gas, liquid, or solid. So here are the factors affecting their solubility, general trends, and example. Class, meron tayong special slide later for alloys. Alloys are also called solid solutions. Kasi nga, solid solute, solid solvent. Okay? And then we have gases. Pwede pala maging solvent, yes. And here are the possible solutes. And here are the possible factors, general trends, examples. Huwag na tayo lumayo. Siyempre, water vapor sa air. Kaya nga diba when you say humid, maalinsangan, saturated ang air with water vapor. Gas in gas. Huwag tayo lumayo. Nasa bridging, air. So alam nyo kasi dapat ang air composed of many gases. Eh wait lang, ano po ba yung magiging main gas? Yung ituturing natin na solvent in air. Siyempre, yung pinaka marami. So you have around 79%, diba? 78, 79% of nitrogen. So ito ang main gas in your atmosphere, in our air. And of course, minor components of oxygen, argon, carbon dioxide, and other gases. Okay? So ayan guys, ang table 1. Hopefully, this will be your reading homework. Ano tayo 1A? Kasi kayo na lang hindi pa nakaka-lesson ito. Okay, so let's have examples here para ma-highlight natin. Gases dissolve in liquids. Oh. So ayan guys, pag increase naman pressure, i-force natin yung mga molecules ng gases, dissolve sila. But in temperature, ito naman guys, tingnan nyo, decrease in temperature, increase naman. So pag nag-increase, mag-ibig sabihin, nag-escape sila. Yes, because they achieve the kinetic energy needed to escape from the solution. So class, para mag-increase ng solubility, kailangan mo ng higher pressure, pero naman sa temperature naman ay lower. Okay, yan class ang effect ng gases dissolve in liquids. So here, meron tayong example. Ito ang inyong carbon dioxide dissolve in your soda. Class, paano natin i-demonstrate ang effect ng pressure and temperature sa normal na daily lives ninyo, kung umiinom kayo ng soft drinks, pero sana mas bawasan nyo ha. You reduce your consumption of this drink. Di ba class, naka-cover. Kunwari yan ay bottle or can. Pagka-open nyo, may sound, di ba? Fizz. Sabi mo, on-site section, ma'am, may fizzing sound. That fizzing sound actually indicates na agad yung effect ng pressure. So, di ba kayo nag-wonder, bakit na-dissolve yung gas sa liquid? Of course, na-pressurize yan. But it was manufactured, it was pressurized, it was covered para class to keep the gas molecules dissolved in liquid. Once you open the bottle and you hear the fizzing sound, you already hear the gas molecules escaping because you are decreasing pressure by opening your can or your bottle. However guys, may naiiwan pa naman na gas molecules inside, don't worry. As long as it's kept cold. If it's kept cold, some molecules of gases are still dissolved in your liquid. Kaya kami nakikita ka pa mga bula-bula, mga bubbles. Mga bakit itong daming bubbles? Because this e-flask containing your Coke or your soft drinks, endorse, your soft drinks guys, ay nag-escape dahil hinihit yan. Okay, hinihit ito class, iniinit to. Gusto nyo ba yun? Soft drinks na iniinit or warm? Siyempre hindi, no? Because the gas molecules are now escaping. So, nag-increase yung kanilang kinetic energy. So, bumababa class ang solubility. Okay? So, I hope clear na class tayo here for this part. Alright? So now, meron tayong special slide on solid solutions. We call them alloys. Paano malalaman kung ano yung base, yung main metal here? Just like in liquid solutions, kung ano yung mas marami, yung main character, yung class ang magiging solvent. So here we have, second column, yung solvent, base metal, main metal. Then maraming solutes. It depends on anong type ng alloy. And at the last column are the key properties. Mamiss kailangan memorize to, of course, not. Additional info lang to guys on the top 5 alloys. Ito ang top 5 na most commonly used alloys in industries. So, nangunguna na class dito ang carbon steel. So, ang carbon steel, no, very known na siya ngayon. Dati kasi stainless steel ang common eh. Ito yung universal alloy, yung stainless steel. Pero class ang carbon steel, it is now gaining popularity because of its strength, affordability, and easy to form. So, it's composed of iron, your base metal, and carbon. Stainless steel, kilalang kilala. Iron pa rin class ang base solvent niya, ang base metal niya. And then here are the minor metals. Bakit popular? Bakit universal alloy ang stainless steel? Kasi alam naman ng lahat, this is corrosion resistant, matibay, durable, and hygienic. Kaya even class in hospitals, ang dami makikita ang stainless steel. Okay? Aluminum alloys. Kung kailangan mo naman ng alloy na lightweight, na corrosion resistant din. At conductor, syempre metal. Syempre klase ay aluminum alloy. So aluminum with the following solutes. And your brownish alloys made of copper or brass and bronze. O, diba? So dapat kilala nyo class ang top 5 alloys in the industries. These are solid solutions. Okay? Next. So now we're done with the basic concepts up to solubility. So now we move on to solubility rules. Class, kailangan memorize nyo to. Talaga ma'am, support exam ba? Walang ibibigay. Wala guys. Kaya kailangan memorize nyo to. No? Dapat freshman year pa na nabigyan ng klase sa inyo nung Gen M era ninyo. Solubility rules help predict whether a substance will dissolve in a solvent, typically water. These rules are based on empirical observations and guide chemists in determining the solubility of ionic compounds. O, klase na itong problem ko. Will a precipitate form if sodium chloride is mixed with silver nitrate? Meron kayong example dyan. Siyempre, tinan nyo class. Sige, uulit ang video na ito. Tinan natin. Initially, your two solutions are clear. Look, clear and colorless. But when they mix with one another, yun, nagiging cloudy ma'am. Yes, because they form a white precipitate, which is silver chloride. So when you write the double displacement reaction, the precipitation reaction is just like this. So your ions that are soluble have the AQ symbol, but the precipitate must have the S symbol, meaning solid. It's insoluble. Okay, so I hope class, alam nyo pa rin to. Now, if you're asked about the net ionic equation, ano yun ma'am? Net ionic class, ano ba yung ions na nag-form ng precipitate? So it's chloride and silver. And then, meron tayong precipitate na AgCl. Okay, so yan lang ma'am, yan lang po yung net ionic equation is your ions that form the precipitate. Ma'am, paano po yung mga hindi kasama? Yung sodium, yung nitrate, paano po yun ma'am? Spectator ions. I hope you still remember that. Okay, spectator ions, they're just there watching you. Okay, so ayan, hopefully naalala. O class, tingnan natin ang mga solubility rules na sa manual nito. So ginawa kong color code, blue for those always soluble, red naman for insoluble. Kaya makikita nyo class may mga red at blue sa kanaan ng table kasi mga exceptions yun. So ito na class ang always soluble with exceptions, kaya naka-red sila. So group 1, our group 1 ions are always soluble. Ma'am, kahit po ano ka-partner nila, opo, kahit ano ka-partner nila, always soluble sila. Group 17, only chlorides, bromides, iodides. Okay, kasi may nagtanong sa akin, ma'am, paano yung fluorides? Ito kasi class ay laging soluble. So kung wala dito, ibig sabihin insoluble. Okay, insoluble. So ang mga fluorides ay insoluble except kung sila ay kapartner ng group 1 or ammonium. Hindi ko lang nailagay ha doon sa table na solubility rules for always insoluble. So clarify natin. Kaya itong tatlo, chloride, bromide, iodide, sila naman yung laging soluble except if they are paired with lead, mercury, or silver. Example, lead chloride, lead bromide, lead iodide, lagyan nyo ng S yun, solid yun. Mercury 1 chloride, mercury 1 bromide, mercury 1 iodide, lagyan nyo ng S, solid yun, insoluble. Silver chloride, natin nyo kanina, white, diba? White precipitate. AgBr, AgI, mga yellow precipitate naman yan. Okay, ganun class ang paggamit ng solubility rules. Itong sulfate na ang dami kasi sa practices natin, kaya dapat alam nyo, all sulfates are soluble except barium, calcium, strontium, sila na naman, lead, mercury, silver. Acetates, nitrates are always soluble. Ammonium, always soluble. Meron ba kayong technique para madaling ma-memorize to? Meron. Din na naka-arrange na yan. GG, sana. Okay? Kung paano yung mga exceptions? Huwag mag-alala. GG, sana. Pumasa. Baka sir, pumasa. Tumang po yung mga on-site sections here. Lagi nila itong sinasabi. O 1A, if you want, pwede nyo i-imitate, pwede nyo gayahin itong mnemonic device na to. GG, sana. Pumasa. Baka sir, pumasa. Sakto naman. Kasi gusto nyo pumasa, di ba? Sa boards natin. So hopefully, this can help you. So all of the other ions not here, insoluble na sila. Okay? Majority ng mga partner nilang ions, nagiging insoluble sila. So some examples are carbonates, chromates, phosphates, hydroxides, sulfides. Ito lang, marami pa nga. Marami pa class. Example lang to. Okay? Mga common kasi na ions to. So lahat pa ng hindi nakasulat na anions here, tulad nila ng fluorides. Okay? So marami pang iba. Sila naman class ay laging insoluble. Napansin nyo, ang lagi nila class na exception ay group 1 at ammonium. Kasi diba, lagi nga soluble to. Okay, baka sir ulit dito. Okay? So lagi kasing soluble class ang mga group 1 and ammonium. Okay? So hopefully, maalala nito ha, ma-memorize sa class ang mga solubility rules. Now, meron tayong activity. Okay, nanonood na kayo ng online video 1A, dapat marunong kayong mag-participate. So tatawagin natin ang ating first mission here in our first class course, mission, mix, and match. Hindi ba dapat match? Match ngayon sa atin. Yung version natin, match. Kasi nga, we have to know kung merong insoluble solid na mapo-form. So if you want guys, in every case, pwede kayong mag-pause. Demonstrate natin ha. Case 1. Ito yung first problem kanina. If you mix silver nitrate and sodium chloride, will there be a precipitate? Yes, we know. At ito class ay ang AgCl. So mamaya pong gagawin namin while watching this video. You're right. The double displacement reaction. Mag-practice ka naman. Nagpag-usulat ng tamang formula. Huwag tayong feeling guys na talagang master na alam ko may mga nagkakamali pa. Kahit sobrang simple. Kahit nasa Cambridge natin to, no Gen Chem to guys. Make sure hindi kayo nagkakamali sa sobrang simple na bagay. Okay? AgNO3 plus NaCl will produce AgCl and NaNO3. Bukod dyan, i-balance nyo na rin. Okay? Para ma-practice kayo for stoic later. Okay? So yun guys ang case 1. Next, case 2. Let's mix barium chloride and sodium sulfate. O 1A ha, and all the rest, nanonood ng video na to, sa mga nag-make up ng on-site sections, you can pause, okay, to give yourselves to participate. Give yourselves a chance, the opportunity to participate, write the complete double displacement reaction or precipitation reaction, and then i-highlight natin guys, maths ba sila? I-highlight niyo yung solid. Okay, so kayo nang maging responsible in pausing and playing the video. Alright, so this is BaCl2 plus Na2SO4, o magbabalance kayo kasi may 2 doon. May precipitate ba? Yes, barium sulfate. For recall, all sulfates are soluble except baka sir, pumasa. So nandun si barium. So siya ay precipitate. Next, case number 3. Let's mix potassium nitrate plus sodium phosphate. Pause if you want to answer. So we have KNO3 and sodium phosphate, Na3PO4. O, anong sagot? May precipitate ba? No precipitate. Bakit? Kasi class, itong mga ions na to are always soluble. Kahit mag-switch pa sila, pareho tayo may sodium and potassium. May nitrate pa. O, di ba? So, all group 1 ions are always soluble. I hope remember nyo yun. Next, case number 4. Let's mix lead-2 nitrate and potassium iodide. So, PbNO3, quantity 2, and Ki. May precipitate ba? Yes. So, it's a match. So, we have PbI2, yellow precipitate to guys. Yung unang dalawang precipitate, AgCl and barium sulfate, parehong white. Pero ito, PbI2, meron tayong class later sa qualitative analysis of ions to confirm lead, mag-add ng iodide, yellow na precipitate ang result. Okay? I hope class clear tayo sa apat na cases. Next, for case number 5, calcium nitrate and sodium carbonate. So, please pause for a while if you want to write the reaction on your own. So, calcium nitrate, Ca, quantity NO3, 2, sodium carbonate, Na2, CO3. O, class, ano ang case na to? Uy, it's a match. You have calcium carbonate na white precipitate. Okay? Case number 6, let's make sodium hydroxide and iron 3 chloride, ferric chloride. Okay, man. Class, kaya ang dami kong cases eh. Kasi maraming anions here to practice your knowledge on polyatomic anions. Kailangan alam nyo. So, ma'am, is it a match? Yes. Makaka-form class ng iron 3 hydroxide na insoluble. Commonly class, ginagawa to sa gravimetric experiment. Next, case number 7. Let's mix ammonium nitrate and potassium bromide. So, Na4, NH4, NO3, and KBr. O, class, dapat dun palang gets nyo na it's not a match. Walang precipitate na ma-form. Because all of these ions, your ammonium, your nitrate, and your potassium, ito guys ay mga soluble. Yung bromide natin, di ba? Yung pumasa lang hindi nagiging soluble for bromide. And last, case number 8. Let's mix lithium chloride and sodium acetate. O, alam ba kung paano isulat ang acetate? So, class, normally we write acetate as CH3COO-. However, sa board exam, baka magulat kayo kinocondense yan. C2, dalawang carbon, tatlong hydrogen, dalawang oxygen. O, ayan na. That's another way of writing acetate. Okay? So, parang mga lahat naman ng soluble, yes. So, there is no precipitate. O, ayan, class. O, sa mga on-site sections na una ko turuan, hindi pa tayo nagkaroon ng ganitong mission, di ba? So, hopefully, guys, you find now na nag-add ako ng practice. Okay? So, this is the mission here to mix and match. Okay? Now, we move on class 2, the next subtopic, units of concentration. Kailangan ba alam namin lahat? Of course, konti pa nga lang ito eh. Ito pa nga lang yung mga common units. Percent, very simple. And then you have molar, mole per liter of solution, molal, mole per kilogram of solvent. Kaya nga class, kailangan nyo ng density. Tsaka molar mass, if you want to convert, okay, yung dalawang factors, conversion factors na kailangan ninyo. Normality, equivalence per liter solution. Merong conversion class ang molar to normal. Kailangan alam niyo yan. And ang ppm, at parts per billion, ppb, ginagamit for trace analysis. Lalo na kung sobrang konti lang na-analyte in your sample. Okay? So guys, tayo ay mag-practice. The next mission, convert. Magko-convert tayo from one unit to another. Class, ito na yung madali eh. Ito yung madaling way ng problem solving here sa solution, sa solubility lesson natin. Kaya dapat, tama kayo dito. Okay? A concentrated ammonia solution contains 28% by weight of ammonia and has a density of 0.899 gram per ml. Calculate the molar concentration of ammonia in the solution. Very easy. You are asked to convert weight percent to mole per liter. So class, ang pinakamadaling approach or atake dito, dimensional analysis. You look at your conversion factors. You have here your density. Siyempre, pwede may calculate ang molar mass. And ang first na given ay percent by weight. Pag percent, it's always over 100. So, 28 grams of solute over 100 grams of solution. Class, if you see yung mga conversion factors ko here ay medyo kakaiba sa arrangement niyo, it's okay. The sequence does not matter, but the units. Okay, the units matter. Kailangan maging mole per liter para masabi niyo na tama rin kayo. So, next, I will be using the molar mass. So, pwedeng mamaya na yan, pero sa akin, second step ko na siya. So, yun ang molar mass ng ammonia. So, now we have mole ammonia. Next, I'll be using the density. So, cancel. Mamiss ang density ba? It's a property of the solution. Kasi akala ko property yan ma'am ng solute eh. 0.899 gram ammonia per 1 ml ammonia. Walang ganun class. Ang density ay property ng solution. So, it's 0.899 gram solution per 1 ml solution. And of course, if tinakas natin, kailangan na-convert yung ml to liter. Plus, huwag malilito. So, one thing may nag-chat sa amin na na-confuse siya dun sa milli. Okay, sa milli class na SI prefix. Sabi ko, huwag mong kalilimutan na kilo pala siya na nito. Naalala ko lang bigla ngayon. So, sana kasi, okay, malilito sa mga SI prefixes natin. So, ang common na ginagamit ay milli and kilo. So, kapag milli, so 1 liter is 1,000 milligram. O, diba? Sana huwag kalilimutan. 1 gram is equal to 1,000 milligram. Okay? So, huwag malilito. Class, bigla ko tuloy naalala. May nagpanic na student. Nalimutan niya ang mga SI prefixes. Guys, meron tayong bridging. Diba? Sa matter na lesson, tinuro ko yung sa inyo. Sana naman class, balikan nyo. Hindi kayo pwede magkamali sa sobrang dali. Madali na nga eh, diba? So, yun ang chance nyo para tumama. I-reserve nyo yung magiging konting mistakes ninyo sa mga super mahirap talaga na topics. Okay? So, everyone na nanonood ng video na to, please get the answer in your calculator. 28 times 1 times 0.899 times 1,000 over 100 times 17.034 times 1 times 1. Mamataas talaga ang answer, opo, kasi ito ay concentrated ammonia solution. So, answer is 14.8 molar, mole per liter. Kasi nga, concentrated ito. So, pag nasa lab kayo at gumamit kayo nito, make sure mag-dispense kayo under the fume hood. Kasi class mabaho ang ammonia. Okay? Not good ng kanyang odor. Madali lang. Okay, next. Calculate the normality of 245 grams of sulfuric acid dissolved in 1 liter of solution. So here's your procedure. Gram solution per liter, gram solute per liter solution. Nagagawin yung mole per liter, nagagawin yung normal. Okay, game. So if you want, you can pause. Okay, before you proceed in watching the solution. So ito class, ang first step, convert natin ang percent to molar. Ang gram, gram pala, percent yung kanina. Itong gram solute per liter into molar. So class, huwag naman kalimutan na napakadali conversion ng mass to mole. Just divide by the molar mass. Sakto naman 1 liter lang siya, divide by 1 lang. So this is around 2.5 molar. Okay, paano naman ang conversion ng molar to normal? Madali lang class. Kasi ang normal ay equal to molar times n, the number of equivalents. If it's an acid, like sulfuric acid, you just look at the formula. 1 mole of sulfuric acid will produce 2 moles of protons. Ganun lang yun. Oo, ganun lang siya. Pero pag iba ng equilibrium, iba na lang gagawin. Okay, nagkataon lang na ito class ay sulfuric acid. So that will be involved in a future acid-base reactions. It will produce 2 equivalents, okay, of protons. Kaya times 2. So ito class ay 5 normal. Or pwede rin equivalents per liter. So yan class ang unit ng normal. Okay, very easy. Kailangan nyo ng class mag-practice na conversion. Next, dilution. Dilution class is very common when you want to prepare a solution. Paano ma'am? Measure a certain volume from your stock. and then ito ay known na concentration. Ilagay mo sa next class mo, and then dilute to mark. See, ganun lang. Ito class ang mga symbols natin. C for concentration, V for volume. So those na may subscript na 1, this is your stock solution, the origin. Yung may 2 naman, this is your dilute solution. So it's just ratio and proportion. So ano po kayo papakopit sa amin kahit ano, kung galing sa stock o yung new solution. Kaya meron tayong ganitong problem in your manual. The next mission, to dilute. How should one prepare 500 ml of 0.25 molar sodium hydroxide solution from your stock na 1 molar? So mga hinahanap po ba ay V1? Yes, V1 plus ang hinahanap. So sana, naalala pa 1A ha, paano mag-transpose. Kailangan i-troubleshoot yan kung kayo ay nanghihina na sa math. Math is very important in our subject. So V1 is equal to C2V2 over C1. Ta-transpose lang guys. Okay? And then, ito na, substitute the values. So 0.25 times 500 over 1. Kahit ba anong unit pwede, kahit molar, normal, percent, ppm, yes, basta consistent, they will cancel. So you will be needing 125 ml of your stock solution and you will transfer it into a 500 ml volumetric flask. Dilute the mark with your water. See, napakadali. Next, a solution was prepared by transferring 60 ml of 85% by volume phosphoric acid and diluting it to 1 liter. What is the concentration of the new solution? So we are asked for C2. C2 is equal to C1V1 over V2. So 85% times 60 over 100. You have 5.1% of your new solution. Halama, madali lang pala. Exactly. Kaya class pag ganito ang tanong sa boards, whether it's in order analytical, dapat tamaan nyo ha. Please, kasi sobrang dali ng class ng dilution problem. Very common to in chemist and chemtech board exams. Yay! We're done sa medyo madaling parts. So now class, we move on to solution stoichiometry. Mamano yan? Stoic lang to class, pero ang involved ay solutions. So ang common task na scenario nito, may pagkahaluin na ng solution. So tanong sa'yo, normally, concentrations nila. Lumalabas kasi sa board exam, kaya kailangan alam natin to. Let's look at the steps one by one. Number 1, write the balance equation. You already know this. Step 2, identify your known and unknown. Obvious naman, kung ano yung known, nasa given, unknown hinahanap natin. 3, compute for moles of species. Mga common ba itong step? Oo naman. Common na step sa stoichiometry, ang pag-compute ng mole. Here, the solution stoichiometry kasi class solutions to, ang ibibigay sa atin ay volume. So i-convert nyo lang yung volume in liters. Kasi usually naka-ml yan. And then, i-multiply nyo class yan with the molar. So mole per liter, cancel, cancel. O diba? Teka, bakit ang sulat ko? Ayun natin. So liter times mole per liter. So mga ganun talaga yun. Talagang mole, kailangan i-multiply namin. Syempre nga, kukunin mo yung mole, diba? So kasi dapat normal step na to sa inyo. Normal step na dapat to for all of you guys na kapag solution stoichiometry, solutions ang involved, you want to get moles here in step 3, just multiply the volume in liters and the molar to get mole. Plus, may ibang hirap dyan. Kaya kailangan gets nyo na napakadali lang itong step na to. Ma'am, yung ML, i-convert pa to liters. Siyempre, paano magka-cancel class yung units kung hindi pa rin po? Okay, so please do this. Now, here class, sa slides ko, sa notes ko, for sure na notice ninyo na kapag nag-convert ako ng ML to liter, ginagawa ko siyang decimal. I move the decimal point to the left 3 times. Kasi nga, 1 liter, 1,000 ml. Kasi, pag nag-type ako, less characters yun compared to having times 10 to the negative 3. O diba sa calcu, ganun kayo. ML times 10 to the negative 3, yun yung liters. So I hope clear tayo na pareho lang ang scientific notation sa decimal form na pinapakita ko. Step 4, you use the ratio. So you look at the ratio guys, 1:1 ba? 1:2. O naalala ko, nahirapan kayo dito eh. Nung stoic pa lang. Dapat nga class, nung nasa college pa kayo, undergrad, yan stoic na yan, very easy para sa inyo. It's just ratio and proportion. So mga nahihirapan sa stoic, remind yourself, this is just ratio and proportion, but ako nahihirapan. Sabi naman ni Ma'am Mitch, dapat madali lang to. Step 5, convert moles to the side units. Now, diba nag-compute kayo ng mole, tapos nag-ratio na kayo, alam niyo na yung limiting charges reactant. Paano kung ang question ay in molar? So paano yun ma'am naka-mole? You get the final volume. Bakit naghalo mo ang solution? Nag-combine. Siyempre class, pati volume no, tataas, nag-combine. So assume the volumes are additive. Okay? And then, meron ka ng final volume, total volume, yun ang ipag-divide mo sa final moles to get the molar, kung yun ang hinihingi. So mga steps 1 to 5 lang pala ang mahalaga dito. Yes, kasi 6 to 10, checking na lang. Okay? So class, unknowingly, nagagawa nyo itong steps na to. Promise, unknowingly, nagagawa nyo na itong steps na to. Hindi ito bago sa inyo. Some of this or most of this, ginawa na natin in our practice test 5 sa Cambridge. So kailangan ko lang kayong ibalik sa stoichiometry. Alright? So class, ito ang nasa manual na problem. After mixing 30 ml of 0.3 molar calcium nitrate and 15 ml of 0.6 molar sodium fluoride, which ion is present in solution at 0.1 molar? So class, step 1, ito na. This is our balance equation. Precipitation to, fluoride insoluble to. Calcium fluoride is the precipitate. Now class, I need you to know na yung ginawa kong solution in your manual ay incomplete. Incomplete to kasi gusto kong sagutan na lahat ng ions, hindi lang isang ion na 0.1 molar, lahat na, lalahatin natin. So class, I hope it's okay na hindi ko na i-elaborate pa ito nasa manual kasi nga incomplete to. Pero mamish, tama pa rin to. Gusto ko lang i-elaborate ang computation na per ion. So lahat ng ions class, i-compute natin ang molar concentration nila para complete yung learning natin. Everybody, please refer to my new solution here. Longer and more detailed. Okay? So class, the two solutions are calcium nitrate and sodium fluoride. So here is calcium nitrate. Bakit may ganito ka? Para makita nyo yung kanilang ionization. Mag-ionize sila, di ba? Para bago mag-form ng products. So your calcium, 0.3 molar, 30 ml, ginawa ko lang siyang class liters. Okay? So you have 9 times 10 to the negative 3 mole for calcium. E paano yung nitrate? Bakit wala pa? Class, I need you to know na dalawa ang nitrate sa reactants. Therefore, times 2 dapat siya ng calcium. Okay? With sodium and fluoride, pareho lang silang 1:1. So whatever is your initial amount, yun nyo ha, 0.6 mole per liter, concentration na yan, 15 ml, nakakonvert na yan sa liter, 0.009 mole, yan din ang initial mole ni fluoride. Okay, so wala pang hirap class ha. Nagko-compute pa lang tayo ng kanilang initial moles. Kaya pala gusto mo ganito para clear exactly. Kasi hindi ko siya nagawa in the solution that I placed in your manual. Okay, so dito ko siya ginagawa ngayon in the slide in our crash course. And then guys, tingnan niyo to, nakatali yung 4 na ions. Let's just copy our initial amount. And now, think of the reaction. Mamich, ano nga po yung formula ng precipitate? The precipitate is calcium fluoride. Class, ito ang precipitate, calcium fluoride, CaF2. Alam mo, nahirapan talaga ako paano kunin ang limiting reactant. Let's go back to the basics from bridging. LL, the species present in the lesser or least amount is the limiting reactant. The limiting reactant is always consumed completely. Okay, consumed completely. So tingnan nyo class, ang calcium at fluoride. Paano ko malalaman? Pareho naman silang 0.009 mole. Class, look at the formula. CaF2. O diba kapag ginamit nyo yung technique natin from bridging, kung saan pwede mong i-divide yung initial mole by the subscript, kung ano yung lesser in amount, mas konti, okay, yun ang magiging limiting reactant. O yung calcium divided by 1. Si fluoride, by 2 kasi nga CaF2. Halaman, kahit pala walang calcium, malalaman ko that fluoride is the limiting reactant. Exactly. Plus mental lang yun ha. I-mental nyo lang kung paano kumuha ng excess and limiting. Whichever ion or species ang lesser sa ginawa natin technique based sa formula. So 0.009/1. Kasi sa formula ng precipitate ng calcium fluoride, CaF2. Balikan nyo ang bridging ko, nalimutan yung tinuro ko yan. Sa practice test discussion ko na-reveal ang technique na yun. Tapos ang fluoride, o diba 0.009/2, bang, siya yung mascote. Okay, siya yung magiging limiting reactant. So mamit ubos lahat yan, oo, ubos lahat yan. At dahil 1:2 ang ratio, yung calcium half lang ang magre-react sa kanya. 0.0045 mole. O clear tayo ha. On-site section sa na-remind ko na kayo about this. Online, sana nag-gets nyo. Lalo na kayo online na pinapanood nyo dapat yung mga video every now and then. Ginusto nyo yan. Ginusto nyo na sa online, so i-maximize ninyo. Yung iba ginusto sa online pero hindi naman nagpa-follow ng schedule. Ano yun? Diba? Gusto mo ng mga video, anong ginagawa nila sa accounts nyo? Ano, natutulog lang. So cater ayaw na. Diba? So sana kayo sama kinig sa akin. Diba? Nakapag-remind pa ako kahit sa crash course video natin. So paano po yung final amount? Eh di na natin. Minus natin class kung ano yung naiwan. Kasi nga nag-react na, diba? So this is your remaining amount for calcium. Paano yung spectator ions? Spectator nga, hindi sila kasama class sa formation ng precipitate. Andyan pa sila. And they are soluble. Hindi sila class na bawasan. Fluoride, totally used up. Again, limiting reactant. Paano po yung final? O class, you can pause for a moment. Kayo mag-compute ng final concentration. Final, ibig sabihin, kunin mo yung total volume. So total volume is 30 plus 60. So that 30 plus 15, sorry. 30 plus 15, that's 45 ml. Okay, so divide everything by 45 ml to get the final concentration. So with calcium, 0.1. Kaya class, 0.1 molar. Calcium yung answer dun sa sample problem sa manual natin. Class, alam niyo ba, ito ay lumabas sa board exam dati. Kaya nga sinasolve ko here sa crash course natin. Para maalala nyo, in case umulit itong question on calcium fluoride. So ang answer sa boards, calcium is the only ion present at 0.1 molar. Kasi ang nitrate mas mataas, 0.4. Ang sodium mas mataas, 0.2. Bakit mataas sila? Remember class, sila ay spectator ions. Okay? They are always soluble. Kaya, may technique tayo. Okay, pala i-share yung shortcut. May technique tayo, guys. If the question asks you to arrange the ions in order, ganito lang class. The two ions na laging mataas, sila yung spectator ions. Sila yung more soluble. O nga no, yung sodium sa nitrate. Paano nalaman na mataas yung sodium, yung nitrate? O, tingnan dito, di ba? NO3, quantity 2. Simula pa lang, revealed na agad sa atin na mas marami ang nitrate, followed by sodium, at syempre, limiting in excess. Okay, mas marami ang calcium over fluoride. So, fluoride kasi ang limiting reactant. Okay, o, di ba? Si ma'am naman, na-reveal pa yung long method, may shortcut pala. Syempre, klase shortcut, wala naman itong exact concentration. Hello. Paano mo malalaman yung exact concentration? Syempre, sa long method mo lang yun makukuha using the principles of using the fundamental, the basic principles of stoichiometry. So, here, may volume. Kaya kasi tinawag na solution, stoichiometry. Okay? So, I hope clear tayo. You have a similar problem na meron in practice test 1. Right? Ito ang last subtopic in solutions. Insolubility equilibrium. Ang solubility product constant. Half pa lang to class ng crash course 1. Meron pa tayong second half ang acid base. Kaya make sure guys, ginagawa nyo ang best na to keep up. So class KSP, ito ang equilibrium constant natin between solid salt and ions in a saturated solution. So, there in table 5, meron tayong iba't ibang KSP expressions. So class, please take note na iba-iba kasi ang stoichiometry ng mga ions. We have 1:1, 2:1, 1:3. Kaya iba-iba din ang kanilang KSP expression in terms of S. So kapag silver, 1 lang. So S times S squared. Pero pag hindi na 1:1 class, ayan tingnan nyo, diba dalawang silver, kaya siya 2S. Eh diba ipapalit mo to dito. So 2S quantity squared times S, kasi isa lang to. So what you have, 4S cubed. Remember, sa box class, S ang ginagamit nila kapag hindi given ang equilibrium concentration. And the rest, please study guys, paano naging ganito. Sa board exam, ito yung lumalabas. S squared, 4S cubed. Huwag nyo ipag-pray ito guys. Pero in case may ganito kahirap, dapat alam nyo kung paano pa resolve. Here in the last part of our lesson, we will discuss the following. Factors affecting solubility. So one by one, we will discuss the following factors: common ion effect, weak acid formation, and complex formation. So ito class, the modified KSP expression, I will not yet derive this. Hindi pa kayo ready. Anachem 1 pa lang tayo. Part 1 of Anachem 1. So I will not yet, don't worry, I will not yet derive the following modified KSP expressions. But since we already know the basics of chemical equilibrium, we can already explain the effect on solubility, kung decreasing or increasing. So guys, game. So please focus on the problem in your manual. Calculate the solubility of silver chloride in pure water and in 0.01 molar sodium chloride. So mga dalawang ang answer here, of course, dalawang pinapakompute solubility first in pure water and then separate naman ang in 0.01 molar sodium chloride. So class default, of course, water ang medium. So the dissociation of silver chloride is just follows. So at the right side, we find the ions. Take note class na ang solubility product constant ay ito ang equilibrium natin between the solid salt, the insoluble solid, and the ions. Okay, so this is what we meant by KSP. So class, KSP is equal to S and S. So S squared. Di ba madali lang? 1:1 lang kasi. So ma'am, pag nahanap natin yung KSP from books, we just get the square root. Yes, just get the square root of the KSP. Constant to. So you'll find this in books. Square root of 1.82 times 10 to the negative 10, you'll get 1.35 times 10 to the negative 5 molar. Ano yan ma'am? It's the solubility of silver chloride in pure water. So in every liter of solution, dissolved ang 1.35 times 10 to the negative 5 mole of silver chloride. If you want this in grams, then use the molar mass. Okay? Now for the second question, what if your solvent becomes, the medium becomes 0.01 molar sodium chloride? So class, magkakaroon tayo ng common ion. Ano yung common ion ma'am? Parehong ion, chloride. Okay? So chloride is now present in the medium. Ano kaya ang effect nito? So magiging bagong solubility na silver chloride. So class, your silver is still S, yung term para sa kanya. Pero ang chloride, ang term na ngayon para sa kanya ay S plus 0.01S. Okay, I hope you can follow. And then, distributive property, I hope you still remember sa math. So S times S squared, S times 0.01S. And class, itong KSP na constant, transposed to the other side. So all of your terms are on just one side, all equal to 0. I hope you remember, we call this a polynomial. So S squared plus 0.01S minus 1.82 times 10 to the negative 10. Class, how do you solve a polynomial like this? Use the quadratic formula. Negative b plus minus squared of b squared minus 4ac all over 2a. However, sa calculator, dapat marunong po tayo mag-quadratic. Mamich, pwede ba i-shift solve class quadratic? For cases like this, I really recommend, we strongly suggest that you use the quadratic function. Meron yan sa calc ninyo guys, promise. We hope na kayo ay nakatapos na ng Math Reaching Part 1 video and Math Reaching Part 2 video. Dapat guys, okay, kasi alam niyo naman, na sa mga problem solving subjects like inorg, anak, and physics, mahalaga ang math. And you don't say na, mami, calculate ko kayo ng calculate ko yan, but you're the one who are inputting the values in your calculator. Your calculator cannot imagine things kung ano gusto mo ipagawa sa kanya. So make sure you, as the exam taker, as the applicant, know how to do the math. Okay, you know the chemistry part, and then followed by the math part. They go together. Hindi pwedeng mamsakin na ako magaling, bahala na yung math. No. Or mamagaling ako sa math, bahala na yung chem. No again. Okay, I hope we're clear ha. Even though guys, online to, virtual to. I hope na-feel nyo yung feelings ko. Okay? So in your calculator, you input your A. Of course, it's just 1. Your B, 0.01. And your C, negative 1.82 times 10 to the negative 10. O sa mga matagal ng graduate, baka nagtataka kayo, Ma'am Mitch, bakit naging negative to? Ganun talaga class kapag nagtatranspose. Okay? When you transpose a term, a value to the other side of the equation, nananegate yun. Opposite siya ng charge niya. Okay? Kaya minus 1.82 times 10 to the negative 10. 1A, you can pause for a while, get the answer yourselves. Do not be contented with my solution, with my answer. These are mine. Kailangan kayo din may sariling sagot. And kung nag-agree ang sagot mo sa akin, edi tama. Okay? So when you get this in your calculator, you can pause if you want. S is equal to 1.82 times 10 to the negative 8 molar. Compare. So you have an exponent here sa default na water, negative 5, and common ion, negative 8. Diba? Lower. Ma'am, explain. Bakit quantitatively lower ang naging solubility? Recall LCP, Chateaubriand's principle. It's as if you're adding more chloride. Yun yung effect. Nag-add ka ng more chloride. So the system is stress. O ano ba ginagawa ng system pag ito ay na-stress? It will adjust. It will relieve the stress. And if you add a certain species, kung nag-increase ang amount, ang concentration ng isang species, guys, ano mangyayari sa shift ng equilibrium? It will shift away from that side. Kaya class, papunta ngayon sa side ng silver chloride, solid, insoluble solid, ang shift ng equilibrium. So it will have the tendency to produce more of the solid, less of the ions, thereby decreasing the solubility of silver chloride. Ganun class mag-answer ng common ion effect problem. You are not contented by the numbers. You should know how to interpret your numbers. I hope we're clear, guys. O sa nagtatanong kung saan galing ang 0.01, andito siya. Okay? So nagkataon na yung sodium chloride ay 1:1. O pag mas na mabuti, this is not the first time you're seeing this, nasa manual to. Okay? Kahit nasa virtual learning kayo, 1A, you already have your manual. Na-ship na yan. Nandiyan na yan sa'yo weeks ago, baka a month ago pa. So make sure you will follow yung lessons natin. And this problem, very easy. Okay? Common ion effect decreases solubility. Next. Okay, meron tayong iba pang mga examples for pictures. Calcium fluoride, yung precipitate kanina, remember, in one of our problems. So before and after, so ito lang sa kanyang saturated solution. And then after adding common ions, oo nga ma'am, na-decrease ang solubility. Equilibrium shifts, okay, going to the side of your solid. So dito class, in this situation, in this scenario, fluoride ang inad. O anong effect? The system shifted. Okay, na-drive equilibrium to the side of the solid, decreasing solubility. Another example, precipitate here, silver sulfate. So ito class, ang initial or before. And then nag-add naman siya ng more sulfate, common ion. Ano nangyari? The system was stressed, it shifted towards the side of the precipitate, away from the ions. So more solid, less ions, again, decreasing, na-reduce ang solubility class. Among the three factors, it's just common ion effect, which decreases solubility. The other two, tingnan natin, calculate the solubility of magnesium fluoride at pH 7. Class, another exact case, exact compound to from the boards before. So ma'am, pH 7, di ba neutral yun? Exactly, that's just your default. Default lang yan. Same nyo kanina sa impure water. Dito, ang default natin, neutral, pH 7. So class, ito ang dissociation ng magnesium fluoride, Mg2 plus 2F minus. So class, ito ay let S, ito ay let 2S. And then, you will apply squared dun sa 2S. Therefore, it becomes 4S cubed. At ang value class ng KSP ng MgF2, 6.6 times 10 to the negative 9. So ma'am, Mitch, kukunin natin yung S. Yes. So S is equal to cube root of KSP over 4. And if you do that, you'll get 1.18 times 10 to the negative 3 molar. So yun ang normal niya, na solubility at pH 7 at neutral pH. What if, kunin natin ma'am, yung solubility niya at a lower pH, pH 3. Sa mga ganun pH 2 nilagay ko, okay lang, pareho lang yung acidic. How does decreasing the pH affect the solubility of magnesium fluoride and why? Diba? Bakit? So class, tingnan natin. So let's have first the ionization or dissociation again of MgF2 and isipin mo, lower pH, meaning ma'am, may presence ng H+, exactly. And between these two ions, kanino kaya ma'am, pwedeng ma-associate ang H+, sa magnesium or sa fluoride? Siyempre dapat alam natin sa fluoride because fluoride is associated with HF. Oh, dapat alam niyo yun. HF, hydrofluoric acid, a weak acid, which will be our lesson later in the second half of the lesson. So weak acids and weak bases have an equilibrium between their acid and conjugate, between their base and conjugate. Okay, so yan, may advanced tayo na portion no, about acids and bases, particularly those that are weak. So class, ang effect nito, fluoride, is also used to form HF. So ma'am, are telling us, involve ang fluoride in both solubility and acid-base equilibrium? Yes, sana all pinagkaagawan. So pinagkaagawan ng fluoride ng solubility and acid-base equilibrium. So ma'am, ano pong effect? The effect is that fluoride gets decreased. Nababawasan ang amount ng fluoride kasi it's also used in the reaction with H+ to form the weak acid HF. So ano nangyayari ma'am sa shift? Classical from Gen Chem 6, your Gen Chem 6 na bridging, kung saan alam niyo na kapag nababawasan, na-reduce ang isang side, the system will adjust, shifting, going towards that side. So here, the situation becomes shifted, papunta sa side ng ions. More ions, less solid. Therefore, this increases solubility. And class, ito na ang second factor, formation of a weak acid increases solubility. Hindi pa tayo mag-compute, hindi pa kayo handa na i-derive ang mga modified KSP expression. Kaya hanggang qualitative lang muna tayo. Okay? So I hope guys, na-gets ninyo why formation of a weak acid increases solubility. Okay? So there you go, the second factor. Third factor, let's again go back to silver chloride. And here's the question, how does ammonia affect the solubility of silver chloride and why? So anong gagawin natin ma'am? Class, dapat alam nyo rin ang complex formation. Kung anong mga species ang nagpo-form ng complex. So let's recall, for 1A, tapos na kayo sa coordination chemistry. You already know, metal and ligand. So for those naman sa on-site section na making up for this lesson, meron din kayong advance in order, pero baka hindi pa kasi nangyayari, baka nauna to. Okay? So silver is a metal ion that can react with the ligand. I hope you remember guys ang ating Lewis acid base reaction. So Lewis base ang ammonia, sir ligand, Lewis acid ang silver. Halaman, kailangan pala alam namin mga complex na ganyan. Plus simple lang to. Kaya dapat alam nyo ang complex na naka-form ng silver with ligands. So itong particular ligand na ammonia, naku very popular itong diamine silver ion. So parang same ba yun sa effects of weak acid? Yes, because your silver is involved in another equilibrium complex formation. Nababawasan siya. It's also used to form the complex diamine silver. So the system will again shift going to the side of the ions. More ions, higher solubility. Okay, tingnan nyo class, may picture tayo. So here sa pipette na to, nag-a-add ng ammonia. As you can see, meron tayong silver chloride precipitate here, pero nung nag-add ng ammonia, boom, ma-dissolve sila. Kasi nga, formation of a complex increases solubility. So ayan na guys, ang tatlong factors affecting solubility. Common ion effect decreases solubility, weak acid formation, complex formation, both increase solubility. So kahit wala pa tayong modified KSP expressions ngayon, hindi pa tayo nakakapag-derive kasi hindi pa tayo ready, alam natin yung effects nila. Yun ang important class. Alright? Congratulations guys. Nakarating tayo sa Mitch list. O 1A, alam nyo naman, di ba? May own branding yung mga coaches yun ng slide. So during our bridging period, may mga pinapakita ko sa inyo, did you know? Diba si Ma'am Chloe, meron mga did you know, tsaka si Ma'am Cube. And then, nagpakita rin ako ng mga RCH, review checklist. Si Ma'am Chloe, meron Chloe cards. Kasi galing yun sa term na Q cards. Siyempre, may modify natin. Si Ma'am Cube ninyo, Qubits. O di ba, bongga? Si Ma'am Mitch guys, may bago akong branding ng slide, the Mitch list. So whenever you see the slide, ibig sabihin class, you're done with the first half, okay, ng lesson natin. So here, in our Mitch list, teka lang, ayan, pakita. Tagalan. Okay, so ito guys, ang mga important equations. So we have molarity, normality, dilution. O lahat yan, dapat familiar kayo ha. So you know the units of concentration, you know dilution, and natatapos ng guys natin sa solubility product constants. So you should know the equilibrium between the solid salt and the ions, sinakan ng dissociation, at paano magsulat class ng KSP expression. Okay? So ito guys, ang first half of Anakemon, solubility, equilibrium.